Okay, welcome back. So we're talking about the OSI Reference Model, and in an earlier video we talked about physical layer 1 and layer 2, which is the data link layer. Now we want to go up to layer 3, which is a network layer. So in our network layer, we're actually talking about logical addressing. Logical addresses. What we're most familiar with, of course, is IP addresses. So you'll hear somebody say, well, what's the IP address of that device? And you'll write off a bunch of numbers. Now here we're going to talk about IP version 4, or IPv4. There's also something called IP version 6. IP version 6, which is a more advanced logical address technology that we're not going to talk about today. Even though it is being used, it's a slow integration from IP version 4, although if you do check on your machines, you might actually see 2 addresses, and that's fine. Now an IP version 4 is actually uses a dotted decimal format. A dotted decimal format. So you'll see something like this. 192.168. 10.5. Dotted decimal. These are your decimal numbers. They're separated by these dots, dotted decimal format. Your IP version 4, or your logical address, identifies where you are in the network. Now before we said there is actually a data link layer, MAC address, and now we have a logical address. Now how are they different? Well, the MAC address is actually associated specifically with the physical port on the device. It's burned in, it's actually a burned in address. So each device will have a MAC address. Now you say, well, doesn't each device have a logical address as well? Well, it does, and it needs to in order to communicate to other devices on the network. But these two are not the same. They look different. This is a hexadecimal number, and like I said before, this is a dotted decimal number. Now we use the logical addressing concept in order to group devices together. So we're going to group devices together. The MAC address, if you were to buy sequential devices from the same vendor at the same time, then you could very possibly group those devices together. However, you can move PCs, laptops, desktops from one room to another, from one building to another, and once you do that, you actually lose that grouping capability. So that's why we invented the logical address concept. So for example, if we had the 192.168.10.0 network with a CIDR of 24, this goes a bit beyond what we're talking about, but I just want to talk about the grouping component. We could group devices in the 192.168.10 network. So everything from 192.168.10 to 254 can be grouped together logically. That means you can put them all together and they can communicate without the use of a router. So that's how the grouping concept works at a basic level. So the device we use in order to separate one network from another network is called the router. It's actually a networking device that separates networks. Okay, so that's our network layer concepts. Let's go up one more layer to the transport layer, and let's talk about that real quick. Transport. Now, just as the data link layer had 2 sublayers, the MAC and LLC sublayer, the transport layer has actually 2 very commonly used protocols. And these protocols are used to manage the transportation of information or data through from one device to another device. TCP and UDP. And we use these protocols for very specific reasons. TCP, transmission control protocol, and UDP, user datagram protocol. TCP, or transmission control protocol, actually requires the destination device to acknowledge that they've received data. So one device, device A, needs to send information to device B. Well, when it sends information to this other device, how will we know if the actual other device got that information? Well, using transmission control protocol, device B sends back what we call an acknowledgement. Say, hey, I got it. It's called an ACK. It's an ACK packet. But basically, it's an acknowledgement. Acknowledgement to say, yes, I got the information. And that's good when we're sending data. Now, so why do we use user datagram protocol? Well, when we don't need that acknowledgement, and what we use for real-time transmission, real-time communications, we're going to use user datagram protocol, real-time communication. It does not require and will not use that acknowledgement packet. So that means when we're streaming video or talking on our cell phones or over a VoIP communication device, we're going to use user datagram protocol because we want that data just to be sent as fast as possible. And the only person that's actually wondering whether or not that data is sent is the person itself. The device itself is not going to record or request that data and acknowledgement to be sent back. It's simply going and going and going. Now, if the person on the other end doesn't hear your conversation quite right, or if the video is not streaming very well, then they're going to do something about that. And they're going to tell the sending person or sending whoever that I didn't get that, could you please resend it, or could you please repeat it? But for real-time communication, we're going to use user datagram protocol. Okay, that's our talk for transport layer. Thank you for joining me. When we come back again, we'll talk about layers 5, 6, and 7. Thank you.